Hi viewers, this is M. Mahadri, lecturer in statistics. Today I am explaining one of the important distributions that is called continuous probable distributions, right? The continuous probable distributions. What is continuous probable distributions? Very simple. A continuous random variable is one which can take uncountable, okay, which can take uncountable uncountable many values in between certain limits, between the certain limits. Okay, what is that? A continuous random variable is one which can take uncountably many values in between the certain limits. Okay, hence it is always described as belonging to an interval, and the functions is known as probability density function. Okay, the order density function is always described as belong to an interval, and the function is known as probability density function, right? This is called PDF. A PDF must be follow the conditions. That is, the first condition is f of x greater than or equal to 0, and second condition is integral minus infinity f of x dx is equal to 1. There are two conditions. So the two conditions are must satisfies the function that is called probability density function. First one is f of x greater than or equal to 0 always, and integral minus infinity f of x dx is equal to 1. Okay, so it should be noted that f of x does not represent, is what that f of x does not represent the probability, right? Does not represent the probability, but f of x dx is the limit probability defined by f of x dx is equal to, this is the function of dx tends to 0, x minus dx by 2 less than or equal to x less than or equal to x plus dx by 2 dx. This is the continuous probability density continuous random variable concept. Now, depending on this future, various PDFs will be discussed in subsequent videos. Okay, I'm explaining the subsequent videos, but based on the nature of random variable, based on the nature of the random variables and their sample spaces, there are many probability density functions. So I have discussed one by one to all density functions. Now first to discuss the distribution. The one of the distribution is rectangle distribution. It is the first distribution of a continuous random variable. It's very simple and easy to understand for common man. The distribution, this is called rectangle distribution, otherwise called, this is called uniform distribution. It's otherwise called uniform distribution, right? What is that uniform distribution? Let be a random variable. Let x be a random variable defined on a continuous sample space. Whatever may be the, what is one? First up, we can take the random variable x and define on the sample space or one-dimensional real line vowel range. Range is a to b. The range is a to b. That means there is certain intervals. So a to b. Range is a to b. Then it is said to follow a rectangle distribution if its probability density function is a constant. Density function is a constant. This is k. Okay, this density function is k and constant, and on the range a comma b, and the PDF is 0 is otherwise out. That means outside the specified range a comma b, right? That a comma b are two real numbers, and such that a less than b is very important. A comma b are real numbers and a less than b such that, and it is finite. And it is finite, it's very important, and is finite. So then f of x is equal to k for a less than k less than b, and is equal to 0 otherwise. This is the rectangle distribution concept. Okay, p of x, f x is equal to k for a less than x less than b is equal to 0 otherwise. What is k? K is a constant value. So we can define the constant, apply the certain limits using the PDF. That PDF is equal to integral minus infinity f of x dx is equal to 1 is the one of the probability density function concept. The total pair is equal to then this is equal to 1. Right, and this can be also written as minus infinity to a in f of x dx plus a to b f of x dx plus b to infinity. That means minus infinity dividing into split into three integrals. So minus infinity to a one integral, and a to b another integral, and b to infinity another integral. Is total is 1. Okay, the first integral value, that means the outside the outside of the limits is 0. So infinity minus infinity to a, this is outside the limits, so value is 0. Okay, this b to infinity, the outside the limits, the value is 0. Okay, inside the limits, a to b f of x dx is equal to 1. The f of x is equal to k, substitute the k value, and integrate value k into x integration, k integration, that means k constant, and integration x and to b, that means b minus a, k is equal to b minus a. This is the probable density function of rectangle distribution. K is equal to 1 minus b minus a. So there the PDF of rectangle distribution is f of x is equal to 1 by b minus a less than x less than b and is equal to 0 otherwise. A comma b are parameters. This is the probability density function of rectangle distribution or uniform distribution. Next one is discuss the character distribution function. What is the distribution function? This is f of x is equal to p of x less than or equal to x. This is the distribution function formula. F of x is equal to p of x less than or equal to x. That means cumulative distribution function. That is p of x less than or equal to x. So x is maximum value. So the upper limit and the lower limit is a. Already know that the limits of the distribution is a less than x less than b. So a is first limit a to x f of x dx. So a to x into f of x is equal to 1 by b minus a. Very simple. It is 1 by b minus a into a to x into this is equal to 1 into dx. So 1 into dx. So integration of x into j to x, and finally substitute the limits x minus a by x plus a. X minus a by b minus a. Very simple. Therefore f of x is equal to x minus a by b minus a. X is equal to a minus a 0, and the term f of x is 0. B x is equal to b, nothing but b minus a, b minus is 1, f of x is equal to 1. Therefore you can easily understand that f of x is equal to 0 and x less than or equal to a, and x minus a, b minus a, the limits is a less than x less than b, and 1 is x greater than equal to b, x greater than equal to b, right? This is the distribution function concept. So what is that? What is the distribution function? F of x is equal to b minus a by x minus a by x minus a by b minus a is the distribution function concept. And probability distribution function is 1 by b minus a. It is very strictly you have to confuse. The probability density function is of rectangular distribution is 1 by b minus a. The distribution function is x minus a by b minus a. It's a very common issue. Okay, right? Next one is mean and variance of this distribution. The rth moment about origin, general formula, the mu r dash is equal to integral a to b x power r into f of x dx. This is the general formula for moment about origin. Okay, put r is equal to 1 or 2 3 and so on. So unsimplify this formula, a to b x power r into what is f of bx and by b minus a into dx, and simplification 1 by b minus also the integration and it equal a to b x power r into dx, right? X power r into dx, and x power r integration x power r plus 1 by r plus 1. So a to b limits there will be 1 by b minus a and b power r plus 1 by r plus 1 minus a power r plus 1 by r plus 1. Apply the limits. So substitute b power r plus 1 by r plus 1, and substitute the lower limit a power r plus 1 by r plus 1 minus. So finally b power r plus 1 minus a power r plus 1 by r plus 1 b minus a. This is mu r dash formula for rectangular distribution. Okay, put r is equal to 1. So what is that? Mu1 dash b power 1 plus 1 2 b square minus a square divided by 2 into b minus a. What is b square minus a square? B plus a into b minus a. Very simple. So b minus a cancel, and finally b plus a by 2 that is equal to mean is equal to mu1 dash, that is equal to expectation of x is equal to b plus a by 2. Therefore the mean of the rectangle distribution or uniform distribution is equal to b plus a by 2. It's very simple. Right. Next one is put r is equal to 2, that is equal to mu2 dash, that is p cube minus a cube by 3 into b minus a, and this is the formula. And this is the formula. Substitute r is equal to 2. So b 2 plus 1 b cube minus a 3 plus 1 3 cube, and b cube minus a cube by, so 3 2 plus 1 3 3 into b minus a, right? See this b cube minus a cube by 3 into b minus a. So b cube minus a cube also written as b minus a into b square plus ab plus a square by b3 into b minus a. So b minus a cancel, and finally b square plus ab plus a square by 3. And variance is equal to mu2 dash minus mu1 dash square, substituting the mu2 dash value and mu1 dash value whole square. And simplification 4 into LCM is 12, and this is 4 into b square plus ab plus a square minus 2 means 12 LCM, and this is 3 times 3 into, so that means b plus a whole square by 4. So 4 3 times 3 into b square plus a square plus 2ab by 12. and that is finally simplification, minus 2ab plus b square plus a square, and simplification 4b square plus 4ab plus 4a square minus 3b square minus 3a square minus 6ab by 12, and simplification finally minus 2ab plus b square plus a square by 12, that is equal finally a minus b whole square by 12. So b2 is equal to a minus b whole square by 12, and the variance is equal to, that means the variance of the rectangle distribution is equal to a minus b whole square by 12. Is very simple formula, and mean is a plus b by 2, mean is a plus b by 2, and variance is minus b whole square by 12, right? So and next one is moment generating function of the distribution. By the definition, mx is equal to expectation of e power tx and integral a to b e power tx into f of x dx. This is the common definition, definition of moment generating function. So expectation of e power tx is equal to integral a to b e power tx into f of x dx formula. So you know that formula, mx that is equal to integral minus infinity e power tx into f of x dx, expectation of x, so e power x into f of x dx, nothing but. So integral a to b e power tx into what is f of x, 1 by b minus a dx. So 1 by b minus a constant outside the integration, and integral a to b e power tx into dx, and 1 by b minus a e power tx by, what is that, in the integration of e power tx by t into a to b. What is that, 1 by b minus a e power apply the limits e power bt by t minus e power a substitution a t by t. So finally you get e power bt minus e power a t by t into b minus a. So this is the m.g.f of rectangular distribution. Okay, and next one is that characteristic function, right? Characteristic function of next one is characteristic function of rectangular distribution. This is characteristic function. So what is that? Very simple. By definition of a characteristic function, pi xt is equal to, what is that, pi xt is equal to pi xt is equal to expectation of e power itx. Very simple, expectation e power itx, that is equal to, what is that, integral a to b e power itx into f of x dx. Very simple, expectation of x, integral x into f of x dx, the formula, that is integral a to b e power itx into 1 by b minus a into dx. Right, 1 by b minus is constant outside the integration, so 1 by b minus a integral a to b e power itx into dx, right? And integration of 1 by b minus a e power itx, so e power itx by it integral a to b, and apply the limits 1 by b minus a, what is that, e power itb minus e power ita divided by, what is that, it, right? So finally get e power itb minus e power ita by b minus a into it, that is pi xt. This is the characteristic function of rectangular distribution, right? This is the concept. Okay, next class we'll discuss another distribution. Have a nice day. Bye.